What tests can I perform to determine whether a polygon is a parallelogram or not? What tests can I perform to determine whether a polygon is a parallelogram or not? Alright, so here's the rules again that you need to write down. A quadrilateral is a parallelogram when, alright, a quadrilateral is a parallelogram when both pairs of opposite sides are parallel and congruent. Okay? A quadrilateral is a parallelogram when both pairs of opposite angles are congruent. Quadrilateral is a parallelogram when diagonals bisect each other. And one more. One pair of opposite sides is both parallel and congruent. Alright, so let's go back up to number 1 and take out, just scratch out parallel here. Both pairs of opposite sides are congruent. If both pairs of opposite sides are congruent, it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. If the diagonals bisect each other, it's a parallelogram. And if one pair of opposite sides is both parallel and congruent, it's a parallelogram. Okay? So that final one, a diagram of that, would look like one pair of opposite sides is both parallel and congruent. So that would look like this. All right, we'll say the top and bottom. If the top is parallel to the bottom, okay, and the top is congruent to the bottom, one pair of opposite sides is both parallel and congruent, then it's a parallelogram. Okay, so here's a diagram of that last one. Everybody caught up? Any questions? All right, so if you're given a picture, if you're given a quadrilateral and you're told that this angle is 56, this one's 7x, 4y plus 4, and 5y minus 26. And you're asked to find x and y so that the quadrilateral is a parallelogram. So for this shape to be a parallelogram, doesn't 56 have to equal 7x? Opposite angles have to be congruent. So 7x would have to equal 56. And if you divide each side by 7, then x is equal to 8. All right? That gives you these two angles being congruent. And your other setup would be 4y plus 4 is equal to 5y minus 26. All right? And solve for y here. So subtract 4y from each side. So 4 is going to equal y minus 26. And then add 26. And 30 equals y. Okay? Look at the shape, evaluate the information given, and then apply one of the 4 rules, okay, of when a quadrilateral is a parallelogram. Any questions on that? All right, there's some, on page 416, there's a coordinate geometry question. Okay, here's the question. Graph the quadrilateral. They give you a quadrilateral graph. Let's see, we got K is at 2, 3. L is at 8, 4. M is at 7, negative 2. And N is at 1, negative 3. Here's what you're going to be asked to do. Graph the quadrilateral. Determine whether the quadrilateral is a parallelogram. Justify your answer using the slope formula. Okay? What will the slope formula tell you about the shape? What do you know about opposite sides in a parallelogram? What do they got to be? They got to be parallel, right? What do you know about parallel lines? They have the same slope, don't they? So what you do when you graph this thing, okay, if we graph this thing here, x and y, and we go 2, 3, all right, and 8, 4, this is K. L is at 8, 4, so 8 and 4. 7 and negative 2 would be here. And 1, negative 3. 1, let's see. 1 and negative 3 would be like here. All right, so if you kind of do this, using the slope formula, you're asked to determine if this shape is a parallelogram. Well, if it is, doesn't KL have to be parallel to MN? KL would have to be parallel to MN. So look, do you guys remember the slope formula? Slope equals y2 minus y1 divided by x2 minus x1. So if you find the slope of this top line and you find the slope of the bottom line, all right, and then you find the slope of the line on the right and the slope of the side on the left, if they're both parallel, then it's a parallelogram, isn't it? Okay? So K to L, the slope for K to L. Or do you really need to do all this? Let's see. Let's look at KL right here, guys. K to L. Slopes rise over run, isn't it? Yeah. Okay. So if we do this, if we rise and run from K to L, how many do we rise?
1.
We run 1. And how many do we run? We go from, on the X, we go from 2 to 8, right? So we go 6. So we rise 1 and we run 6. What do we do down here on from M to N? How many do we rise? We go from, we rise, we go from negative 2 to, or we go from negative 3 to negative 2, so we rise 1. And how many do we run?
6.
We go from 1 to 7, so is the slope of these two the same? Those two slopes are the same, aren't they? Let's do the same thing for the vertical looking lines. All right. From this point N up to K, how many do we rise? We rise from N to K. We go from negative 3 to 3, so you rise 6 and we run 1. All right. And from M to L, we rise. How many do we rise from M to L? Negative 2. Where's L? From negative 2 to 4. We rise 6 again. How many do we run? 1. So are the blue lines, are the left and the right sides parallel?
Yes.
Yes. Okay. So using the slope formula, this is a parallelogram. All right. So you're going to have a couple problems like that today. Coordinate geometry. Any questions? All right, page 418. Through 25. And make sure you check headline for homework. And answer the focus question.